Hello and welcome to Part 5 of 5 of an Introduction to Genetics for the Alberta Science 30 curriculum, Unit 2, or Biology. Pedigrees show how traits are passed on in a family. Circles represent females and squares represent males. A line between the circle and square indicates that a mating has occurred. A line down from this line indicates that offspring were produced. The oldest offspring is always located on the left. Affected individuals are shaded. Heterozygous individuals are half shaded in sometimes. You can find these rules in your data booklet. Traits can be either autosomal or sex-linked. Traits can either be dominant or recessive, as we've already talked about. So a circle represents a female, a square represents a male. Shaded shapes represent family members with one expression of the trait. For example, dimples. Shapes that are not shaded represent members with no dimples in this example. The females have dimples. A horizontal line used to connect the male and the female indicates a mating or a marriage. Lines connect the parents and the offspring. The oldest children are placed on the left, the youngest on the right. In this example, there are 3 children, 2 females and a male. The one male child has no dimples. So here's generation 1, here's generation 2, and here's generation 3. Those are indicated by Roman numerals. You label each member of the generations from left to right. Females are always circles and males are always squared. So generation 1, 2. Generation 1 has 2 individuals, Generation 2 has 7, and Generation 3 has 6. How many children did 1, 1 and 1, 2 have? They had 1, 2, 3, 4 children. What was their sex? Female, female, male, female. Which one was their oldest child? This female here. 2, 1. Assuming that having dimples is a recessive trait and no dimples is a dominant trait, write the genotypes for all the individuals in the pedigree. So, she doesn't, no dimples is dominant, so she doesn't display dimples. He does, so he's little d, little d. She's little d, little d. He, because both of their offspring are have dimples, he's big D, little d. She, because she gets 1 dominant, she has a chance of 1 dominant or 3 recessive. She's big D, little d, big D from mom and little d from dad. He's affected, so little d, little d. She's affected, little d, little d. She is not affected, big D, little d. He's affected, little d, little d. Affected, big little d, affected, little d. Heterozygous, big D, little d, little d, little d, little d, little d. What is the chance that the next child of individual from here, 1 and 2, will have dimples? So you do a Punnett square, the male on the side, little d, the female on top, big D, little d. 1, the chance is 50-50. 2, they can have a 50-50 chance of producing a heterozygous offspring or a homozygous recessive offspring. What is the chance of the next child of 4 and 5 will be a boy with dimples? 4 and 5, 2, 4, and 5 are here. Little d, little d, little d, little d. It's 100% chance of dimples. but only 50% chance it will be a boy. Because that's a 50% chance. Autosomal recessive and autosomal dominant are two forms of inheritance. AA is affected, may skip generations. Two unaffected individuals may have an affected child because they are carriers. So they could be heterozygous for the affected allele. Autosomal dominant, in this case, both the homozygous dominant and the heterozygote are affected. It does not skip generations. You only need to have one affected to be affected by the disease. Modes of inheritance: sex-linked recessive or sex-linked dominant. XAY is affected because remember that males only need to have one affected gene to be affected. Little a is affected. Males are mostly affected. Girls must have an affected father to be affected by the condition. All sons with affected mothers will have the disorder. Big A, little a, all males are affected, as well as females that have big A, or big A, little a genotypes. Males are mostly affected. All daughters with affected fathers will have it. Distal symphalangism, I think is how you say it, I'm not sure. So disorders of the hand and the feet, especially fingernails and digits. If you have a mother who is affected, or you have a mother that's affected and a father that isn't affected, but they have an affected son, this is an autosomal dominant trait. Xeroderma pigmentosum, so that may skip generations. Two unaffected individuals can have an affected child. So this is recessive, and people can be carriers. Albinism, is it recessive dominant or sex-linked? So you have two recessive individuals producing one affected male, one affected female, one carrier, and one carrier male and one unaffected female. This would indicate to me that it is not sex-linked and it is recessive, because you cannot be a carrier with a dominant condition. Premature balding. The slashes indicate that the people are dead. So everyone from the first 4 generations are dead in this chart. It's an autosomal dominant condition, so it's passed on to affected individuals. There are no heterozygotes showing up there. Pedigree analysis, what is this showing? So you have, we don't know we know that in generation 4 you have one affected male and one affected female. We know that these two individuals mated. The double line means it's consanguous mating, which means that they were related and they got married. These two individuals were heterozygous for the trait. They produced 2 affected individuals and 1 unaffected individual, which means that their parents or one of their parents had to be carriers of the condition, as well as it indicates that their grandparents or great-grandparents were carriers. That indicates inbreeding. Why is inbreeding not recommended? The chance of recessive conditions showing up in offspring is increased. So here's another pedigree analysis. Again, this shows a dominant condition. The male is giving, the male is affected. The female gives X chromosomes to her sons. None of her sons are affected. She's not affected. The male gives an X chromosome to each one of his daughters, and all of his daughters are affected. This daughter gives an X chromosome to her son, and an affected X chromosome to her son and to her daughter, but not to these ones. So it's X-linked.